Hello and welcome to Kubernetes, another workload for Veeam to protect. Today's webinar is sponsored by Veeam and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech Media, and I'm excited to be your moderator for this special event. Now, before we get to today's great content, we do have a few housekeeping items that will help you get the most out of this session. First off, we do want this to be an informative event for you, so we encourage any questions in the questions box in your webinar control panel. So not only will we have team members responding to questions during the live event, we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you ask. And I'll just say right up front, we've got two dynamic presenters today who will be, watching that question console and pulling out questions, as they come in, if they're relevant to where they are in the presentation. So type those questions in as soon as you have them. The Q&A panel is also the place where you can let us know about any technical issues that you might be experiencing. A browser refresh is going to fix most audio, video, or slide advancement issues, but if that doesn't work, just let us know in the Q&A and we'll provide further technical assistance there. Now, next, in the handout section of your webinar control panel, you'll find that we've got several great resources. I'd especially like to call your attention to several of them from Kasten by Veeam. So there's a blog introducing Kasten K10 version 6.5. There's a Forrester report. There's a GigaOM report, and there's a Kasten K10 PDF. So I encourage you to access those resources now and share them with your friends and colleagues. Now, finally, at the end of this webinar event, we will be awarding a $250 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for that prize. The official terms and conditions of the prize drawing can be found in your handout section as well. Just scroll to the bottom and you'll find the prize terms and conditions link down there. Now, one of the best benefits of this event is that opportunity to ask a question of our expert presenters. So to help encourage your questions, we have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. So after the event is over, we'll look at all the questions that came in, pick out the very best one, and contact that prize winner. So with all that out of the way, let's get to today's great session. So it's my pleasure to introduce you to our presenters today. We've got Matt Slaughton, who's Principal Solutions Architect for Kasten by Veeam, and we have Matt Schmidt, US Public Sector Sales Director for Kasten by Veeam. So Matt, welcome. Thanks for being here.
Awesome, Scott. Thank you. Always a pleasure. And just for the audience, you guys can call me Matt S for short to keep it easy, so that way we don't confuse who's talking.
Yes, Mr. Slaughton and Mr. Becker, thank you for having us. We're looking forward to today's presentation about Kubernetes, another workload for Veeam to protect.
Absolutely. So without further ado, let's go ahead and dive in, Matt. And just to reiterate too, what Scott mentioned, please, guys, throw your questions in the Q&A. I definitely want to keep this interactive. It makes it more interesting, hopefully, for you, but also certainly for us. And yeah, with that, let's go ahead and dive in.
So as the slide builds out, just kind of want to bring to the forefront how prevalent Kubernetes and containers are in our everyday life. So it doesn't matter what do we do during the day, access a web browser, our smartphone, a tablet, a laptop, a workstation, doesn't matter. There's this systems of engagement where we interact with applications, whether it's Yahoo or email, X, formerly known as Twitter, YouTube, Netflix, Hulu, whether it's Salesforce, Office 365, the pharmacy, whether it's booking a trip, online shopping, e-commerce, checking the status of a charge on your vehicle, credit card payment. All of these items that surround us were either born in the cloud or they've been modernized to run in the cloud, taking advantage of Kubernetes and containers. And so what's interesting is this is the expectation that we have in terms of how we engage with these systems. And naturally, we want this in every aspect of our daily life, especially the workplace, whether we represent a commercial institution, state and local, higher education, the US federal government, what have you. This is the type of experience that we want. However, within most of our organizations, unless we've just started business within the last 5 years. We have a lot of technical debt or applications that have been around for quite some time. And perhaps some of those applications are not a priority to modernize, leveraging microservices and containers. They still have some shelf life left, but other applications that are very, very important to mission outcomes or business objectives, they may have a higher priority to be refactored and to take advantage of containers and Kubernetes. And so really the theme of this presentation is around, one of the big drivers for the adoption of web-based applications is the fact that all of these applications in the background are continuously changing, and they don't impact us on a daily basis. Like maybe they get updated overnight or some points during some certain time during the day, and it's just always on, always available. And there's a reason why we got to this state. But Mr. Slott, anything else you want to add to this slide?
Absolutely. And I love this slide because I think it really underscores, in terms of what we as consumers, at least in the States, see a lot of, and a diverse set, right? So, we see everything from, kind of like you said, mobile apps. You see Expensify in here. I see Salesforce, kind of cloud native that were built in the cloud, but also, a lot of traditional vendors or government agencies, IRS, we see there, H&R Block, TurboTax, large banks. Important to note there, as you mentioned, Matt, is, no matter where you are in your cloud journey, oftentimes we see kind of Kubernetes or we see cloud native begin to work its way in, whether it's time for refactoring existing apps or for net new. And we've actually seen that quite a bit too, in terms of what some customers are doing. There's a good use case. It's not a logo on this slide, but there's a large consumer-facing gas petrol station, if you will, and they have actually containerized a lot of their legacy applications so they can actually piecewise upgrade it. Now it's no longer monolithic, which I know we'll touch upon here in a second. But I know there's probably a lot of folks at different parts of their journey, towards cloud native, or maybe just dipping their toes, or maybe there's some folks in this call that are deep in it and have multiple Kubernetes clusters spread across multiple cloud providers or on premises. But the important thing to note is, we're all on a journey together. We're all learning together. But there's a lot of opportunity, I think, is the key here. And there's a lot of us kind of rowing in this direction together. So we just want to know, kind of set the landscape here, and we'll talk about, potentially how we as a company, but also, just as practitioners, can hopefully help some of the audience here on their transition to cloud native.
Yeah, let's go to the next slide. So really the big driver for us to start more responsibly taking advantage and utilizing our compute infrastructure is really what started to happen at the end of our last century, heading into the year 2000, where we had a big issue with applications that were coded with just 2 characters for the date, and we had this big effort underway to re-architect and rewrite many of these applications. And also, we realized during this time that applications and within organizations were very much monolithic, meaning one big, massive system where everybody was sharing the compute infrastructure, where that compute infrastructure was sized to some peak load that may take place over the course of the year. And if we had to do any maintenance on the application, it was very laborious to break down the application to get to the point where if we just had to change the oil on the vehicle or the tires on the vehicle, or give the vehicle a refresh, and then as you built it back up, things would get broken. And so we really started to have an appreciation for it. It's very expensive to size your infrastructure to some peak workload that may or may not occur during the year. And there's also so much compute capacity that's out there that other folks that have availability that you could potentially leverage and lower your cost of ownership. And so we started to get into this mode where we're looking at different ways of getting away from monolithic infrastructure. And we got to this point where you can use this ship container analogy, where the ship is always in motion. The containers can be swapped in and swapped out without the ship ever changing its course or speed. And basically that allows you to get the continuous uptime. And that's what we see on the smartphone and these web, these systems of interaction, is they never go down. but new capability is constantly being introduced. Feedback, the stickiness of the application is being fed back into what we call a DevOps, continuous integration, continuous delivery process. And so now this is kind of the oasis that's out in the distance that everybody is moving towards. And it's not something that happens overnight because there's a lot of infrastructure that's already in place. And so really it comes down to organizations starting to prioritize which applications do they want to refactor, which are the ones that are most critical. And one of the things that we see in the state and local and higher education governments is these applications are typically those that bring revenue into the organization or maybe affect student affairs or payroll or taxes or what have you that's financially related that are available 24/7. But anyhow, we can be all over the map. We see some parts of state and local higher education where it's the Department of Transportation that's using streaming data to indicate where you might need salt, or there's a drain that's clogged that you need to deploy a service, or it could be a speeding ticket or collecting tolls. But there are so many different examples of where to get started. But the key point here, to leverage containers and microservices in this new system of interaction, it's not something that's in the future. The future is now. It's just we're starting to build momentum. Back to you, Matt.
Absolutely, yeah, and it touches upon one of my favorite thought experiments. The ship of, was it Theseus, was in terms of replacing parts as it sails across the ocean. But thought experiments aside, you bring up some really good points in terms of that modularity and flexibility, right? So containerization and microservices really introduced a lot of agility, I think, for a lot of organizations. I really like that you brought up the Y2K example. I think probably many of us on this call remember, the scramble and the real fear there was, and it wasn't for no reason, right? Everyone kind of jokes that nothing happened, but nothing happened because people managed to turn the ship for the most part prior to that takeover. But if you can imagine, if we could have easily just replaced a module or a container, if you will, that handled time, or updated a simple API call as opposed to having to go through thousands of lines of code. Looking on the left picture here of it's probably more reminiscent of what we were dealing with back then versus now having that modularity. And also, like you touched upon, for a lot of our SLED customers, especially our higher ed and education customers, being able to kind of leverage the capabilities of containerization. I know, speaking from experience, I worked for my university both as a student and then full time for some time after. And budgets are tight. We understand that too, and that's a beautiful thing about cloud native. Is a lot of these resources are open source or based on open source technologies. So it's not costless. We still need hardware in some sense, whether it's in the cloud or in our data center. But we're not paying exorbitant fees for the platform. If we want to run Kubernetes or pull down a Docker image, oftentimes we can, and we can be really thrifty in that sense. And I think part of my time, I was kind of you, Matt. Part of my time at the University of Georgia, I really enjoyed working with some of my colleagues because some of the best creativity came from those limited budgets, right? So. Sometimes we become mad scientists, but in a good way, or at least hopefully for a good way. But I think really cloud native and containerization is kind of the next step in terms of helping us as practitioners really meet the needs of our business or our university or what have you in an agile way. So just to kind of set the stage a little bit more, and talk about where we are today, kind of where we've come from. We have to look at this kind of on a broad timeline, right? So and hopefully this resonates with some of those on the call. But starting on the left there, kind of pre-2000s, as Matt had alluded to, an issue that we faced was kind of this monolithic applications deployed, one application to one server. And it's that peak load problem that a lot of power providers have, right? So you end up sizing your infrastructure for peak demand, which gets very expensive, right? So we have these servers running, and we have to make sure, if we're a retailer, for example, that or maybe the holiday season, we have to make sure we have the infrastructure to support that. But the other 10, 11 months out of the year, it's just running idle. So obviously it became very, very costly. And, that's when we saw early 2000s, kind of that transition to virtualization, right? So we realized we weren't necessarily bound by the same physical problems that things like power providers are with that peak load, right? Where if once we tip over, it's a precipitous fall. Whereas, with computing, we can kind of leverage and schedule and shift resources where they're needed, when they're needed. So really that was a big breakthrough from a cost perspective, from a density perspective. And that was kind of the first step towards a lot more agility kind of in this, last, 30 years or so, to really be able to maximize those resources and flexibility. And I remember how exciting it was to be able to see, exporting an OVA or VM even, and just, that in itself was huge, and not having to worry about upgrades and having to bring things offline, as I could actually export from, forgive me, but one ESX server to another, or whatever, Zen or whatever hypervisor you want to go for. That in itself was, the value was real. So fast forward to 2015, and we started kind of seeing, this buzz around containers, right? And everything was about Docker. Obviously, Docker is still around today. I use it personally. A lot of my home services are running in Docker. I don't need full Kubernetes, at least not yet. Although my wife might argue otherwise in terms of critical services our house runs on. But yeah, 2015, we see kind of this delving into containerization, right? So it's kind of a step forward even more, being more efficient and more granular in terms of what resources we're delivering and how, right? So again, you kind of think of it almost like VMs on steroids. Obviously, it's a little bit more complex than that, but really just accelerating that agility and starting to see kind of microservices pop up where maybe you have one container that's running one point of your application, or another container that's maybe running the data layer, and being able to kind of swap those pieces out. Really helped, again, drive that agile development, helped enable our developers to be much faster. We're not having to recursively test, again, thousands of lines of code, going back to the Y2K problem.
Yeah.
And then, go ahead, Matt, sorry.
Yeah. And also, to me, like, one of the most powerful parts of Kubernetes is all of the vendors or all the applications are interacting with the Kubernetes control plane, data plane, and security plane. And so really that becomes the least common denominator, because if everyone of all the different vendors and stakeholders are taking a control, data, and security plane integration approach and a standards-driven approach, then that makes the interoperability possible. And I think that's one of the most amazing parts of the Cloud Native Foundation, CNCF, is the embracement of Kubernetes and the ability to get the value by focusing on a single approach of control, data, and security.
Absolutely. And yeah, you've balanced me perfectly, Matt, in kind of that last bullet point here, where we start talking about Kubernetes, is really kind of bringing containerization to enterprise, and in a way that, we're not worried about, well, we are worried about single points of failure, but also, dividing up our different service layers, like you said, our control plane, and making sure that, we can really scale this in an efficient manner and really provide that dynamic scaling as well, right? So that's what really Kubernetes brings. So at the end of the day, a container is a container, whether it's running custom code, or if you just pull a container to run, I run PyAware here at home. That's a flight SDR, software defined radio solution, pretty cool to check out for those radio nerds out there like me. But anyways, Kubernetes provides really that orchestration layer and that bridge across services, that security that we're really kind of just missing with just plain containers, and that dynamic load capability, right? So being able to quickly spin up what we call pods, or spin them down based on resource and demand, and really maximizing our return on investment for our infrastructure. Again, whether that's public or private, or sitting in our data center or in our multiple data centers, really driving that flexibility. But another thing that kind of underscores this slide is all of these shifts are significant, right? All of these dots on this timeline, and I think, again, as practitioners on this call, hopefully this is what keeps things interesting, and it's not all continuous in terms of our knowledge, right? We can't just lift and shift, and you can't just take a VM image and blow it up into 1,000 containers and wipe your hands. So I think something worth mentioning and we'll dive into a little bit more some of the complexities and challenges around that. But worth considering, as we have to look at refactoring or opportunities to potentially refactor code here, is it's more than just a lift and shift, even more so than going from those pre-2000s to those kind of 2000s. It's somewhat of a shift in paradigm that we have to be aware of. So a couple high-level items definitely want to cover off too, and talk about those challenges, right? So this kind of, we'll dive in a little bit deeper here, but starting kind of top left, this was based on a recent anonymous survey that Veeam ran in 2023. We ran essentially both among our customers and non-customers, just to capture kind of a state of the market. And what we're seeing was, hopefully some of these numbers are interesting. It was a little shocking, I guess, in some ways, but in others, it's not, right? So we see, for those that that are kind of along our journey with Kubernetes, I'm sure we've experienced some of these issues where 74% of organizations here think traditional and container-based applications can be backed up the same way as virtual machines. Kind of touched upon that earlier, but spoiler, they can't, right? Unfortunately, I guess that's the good and bad news. If they could, Veeam wouldn't have had to purchase Kasten or worry about Kubernetes native backup, because we could just snapshot VMs like we were traditionally and call it a day. Or even it's just, whether it's copying data from a specific disk to another, if it was that easy, it would be great. But unfortunately, fundamentally, the architecture is different. So we have to think of data protection differently when we're looking at Kubernetes. Looking kind of to the right, I think this is what was probably the most surprising and concerning, but also, aligned with kind of previous experiences. We see 85% of companies have experienced at least one ransom attack in the past year. Which, that's a very high number. And based on talking to some of our data scientists that help run this study, they actually think this might be a little low. Even though this was an anonymous survey, not every organization wants to volunteer that they've been a victim or subject to ransomware attacks. And, this is scary, right? We are in 2023. We are seeing fully automated attacks. We see threat actors targeting organizations that, maybe traditionally they could, kind of security through obscurity. But that's no longer the case, right? We need to make sure that we are proactively securing our workloads, our enterprise data, or our universities. And I know, again, speaking from experience firsthand, universities are always tough too, because you're dealing with threat actors both outside and sometimes inside, which leads to some creative problem solving sometimes from a security perspective. But just worth noting there. And last thing I'll add, and I'll stop sucking all the air in the room, Matt, and pause and give you an opportunity to say your two cents as well. But for that 85% number, as we see these ransomware attacks increase, we actually see threat actors targeting organizations they know that are running cloud native infrastructure. And we see them doing that because they know that a lot of this technology is new, so it's ripe for exploitation, right? So again, worth considering, if you were deploying Kubernetes workloads to production today, obviously we can't always tell if something's in Kubernetes or not, but these threat actors are aware this is new, and they are looking for ports, looking for, was it 6004 is what the Kube API listens on, keeping an eye out for that. Matt, anything to add?
Yeah, so what's interesting is really with data production of this type of workload, Kubernetes, really the backup, the DR, the DevOps capabilities that are there, the ability to provide mobility capability. It really comes down to, at the end of the day, DR, it's really your last line of defense. Is how you protect the data within the data that has to survive failure within the Kubernetes cluster. And so when you look at the 93%, it's organizations, a lot of times we have a tendency to believe that multi-cloud, it's selected by procurement. In reality, multi-cloud selects us because we want to consume the service that is the best service available at the time, whether it's a business application, whether it's artificial intelligence, what have you. You want that freedom to be able to consume that service. And so whatever you do with Kubernetes, you want to be able to have the freedom of navigation of wherever that service may reside. And that's one of the big value points of infrastructure as code and hybrid cloud, is this obfuscation layer that gets put over the infrastructure. And all that automation is with infrastructure as code has been done for us, and it's underneath. And so you want the freedom of be able to use GitOps and deploy to the infrastructure of choice, but also the skill set here is different than what we've traditionally been working with. And that's why the market's still coming towards us. It's starting to inflect, but the skill set that's required requires a different type of different way of thinking, and organizations just don't get there overnight. And so one of the artifacts that Kasten by Veeam provides is we actually provide an estate known as kubecon.io, or not KubeCon. It's called, what's it called, Matt?
It's Kube Campus. Yeah.
KubeCampus.io. Sorry, we were at KubeCon last week, but KubeCampus.io. It's a no-cost way of learning about containers and Kubernetes. It's free of charge, self-paced, and so that's one of the additional capabilities that you have. But yeah, back to you, Matt.
Yeah, a really important point, and not to beat a dead horse, but I really like that you brought up, Matt. Kind of how multi-cloud. We don't necessarily choose multi-cloud. Multi-cloud chooses us, and I'm sure that rings true for a lot of folks on this call. We're even just I hate to say it, but it's almost like a new form of shadow IT, where we have developers within our organization, and not to pick on some of the younger crew, but a lot of times we see a lot of younger devs come out of school or come from a different organization that was maybe using a different public cloud provider, and that's what they're used to. And as developers, their job's to develop code, not to help choose a cloud or work through that. So what ends up happening is we see developers go to the clouds that they're most comfortable with, which tends to be one of the large hyperscalers, whether that's an AWS or Microsoft or Google. And, all of a sudden, what became kind of an internal small project suddenly has to be productionized. And we need to make sure that, we can accommodate that multi-cloud journey as well. And, we can't go back to our developers and say, start from scratch, or you need to, basically spend 2 weeks moving this to, I know you've developed it in this cloud, but we need to get it all on this other cloud. We need a tool set or capability that lets us work with our developers. So really important there, from a multi-cloud choosing us. And also worth noting too, vendor lock-in. Right, this is a really important issue that we see a lot. We have been seeing it for a few years, where I won't name any specific names because they all kind of do it. But sometimes you get the carrot dangled, or a great introductory, first year or second year rate. But then once you're in a particular cloud, the vendors know that, right? So they know that they have you and your data's there. I think somebody I see here is asking about persistent data, which is absolutely something we'll talk about. Yes, something that we can move and back up with Kasten by Veeam, but we need to make sure we have a solution that works among these multiple clouds just to prevent that vendor lock-in. And even from a cost thing aside, like you said, Matt, too, sometimes some clouds lend themselves to other different workloads than others, right? So making sure we can move our workloads to where they're best suited. And then this last stat, not to, again, kill this slide, but you touched upon a little bit, but yeah, just that shortage of skill set. So we need to make sure that, for our Kubernetes engineers, for our platform engineers that know Kubernetes, they're already overtaxed. So we need to make sure we enable them with tools that helps make their jobs easier so they can help focus actually delivering for the business, for the university, for, their agency, making sure that, they're not just trying to keep the lights on, but they actually can help move the ball forward. Oftentimes, as we see with those that are really good at what they do, get a lot powered on top of them. So we need to make sure we're empowering them. So a couple of things to cover off here. Just talk about just backup in Kubernetes in general, right? So worth noting that it's more than just backup, right? So I think oftentimes we'll talk to prospects, we'll talk to customers, and I'm sure Matt, you've got specific examples of this. And we kind of ask that first question, are you backing up your workloads today? Are you protecting your workload? Are you protecting your workloads today? And customer will say, I'm in AWS, so they're automatically backing it up. So two things there. One, they may not be. If you read the fine print, oftentimes a lot of the hyperscalers don't guarantee data protection for persistent volumes, or if they do, there's no potential guaranteed SLAs. The other thing too is, okay, if you are backing them up, have you tried recovering them? Because really a backup is only as good as your ability to recover it. So that's kind of our first bullet point here is, if you're taking backups every 2 minutes, that's great. But if none of them are usable, I had an example. I worked at a large bank. They used tape, and for years they had been backing up to tape, but they never actually went through the exercise of recovering from that tape until I think we were there. They went through a kind of a business continuity exercise, and they realized that all of the tape was essentially useless. I don't know if it had been, I don't know the specifics if it had been exposed to some magnets or something, but really important illustrative example there of, yeah, they were taking backups. It was coming back every night and saying, yep, this has been backed up. Tape has been backed up. Go ahead and throw it on the truck and stick it in storage. But they just had mountains of tape that were unreadable. So really important there to make sure that we're actually testing our ability to recover. Also, security. This is kind of going back to that earlier stat around ransomware, but just generally the umbrella of security. We need to make sure that we are putting that at the forefront of our designs and our architecture. Particularly, like I said, for me personally, working at university, it was really interesting seeing how creative some of the students would be at those public universities, or trying to poke at things. And I'd be lying if I said I wasn't one of them at one point. But it's really important that we make sure that we are very secure in the way we're implementing things, and put our best foot forward and make sure that we can proactively monitor this, and also have that stopgap that Matt had mentioned in terms of our worst case scenario. If we are attacked, if we have a ransomware attack, that our data is secure, it's immutable, it's unmodifiable. These are really important things today. And again, we're only seeing this number increase. And the last point too is data freedom, right? So just making sure that we can move workloads among different clouds, right? So kind of that hybrid multi-cloud, right? That hybrid multi-cloud journey. So, multi-cloud, obviously we're looking at potentially different public cloud providers, or even, maybe a managed service provider. Hybrid cloud, we're looking maybe on-prem or a public cloud, or maybe at the edge, but really be able to move these workloads, move this persistent data and the application data with it, right? We're not one or the other. It's looking at things through the application lens, and making sure that we treat Kubernetes backup. We're not trying to back up the Kubernetes cluster. We're trying to back up the applications, because that's what we care about. That's what our business cares about. So really kind of treating the cluster as like an ephemeral cluster, kind of which was the origin of Kubernetes. Anything to add?
Yeah, just one other point. When we start working with DevOps, when we start to adopt containers and Kubernetes, some organizations are going to also adopt DevOps, but also when you do adopt DevOps and you embrace continuous integration, continuous delivery, what we're doing is we're moving the developer and the security and the operators closer to the application than we've ever done before, in which case you might accidentally mismanage a secret, or mistype an IP address, or delete a persistent volume by accident, in which case you still need to do recovery. So the recovery is not just for DR, it's also for restoring and falling back to the last known good instance of what you've been working on. Oops, sorry, got a cat visiting.
Now, this is how we know we're on the internet. We've got a cat. That's awesome.
Sorry.
Oh, everyone loves it. That's awesome. Hopefully it woke anybody up that I put just. So one thing, just to cover off a question here, just because it's top of mind, I want to make sure I'm being proactive here. So Andrew Moore had asked what the URL of the overview of Kubernetes training. That's Kube Campus, KUBE campus.io. So definitely check that out. That is a Kasten sponsor, but it's not all Kasten. It's not all product focused. It's focused on Kubernetes and Kubernetes education. So check that out for sure. All right, let's go ahead and keep an eye on the clock here. So, now we get into, why Kasten by Veeam. I think there's been a few questions here about, persistent data, container workloads, so to kind of lay the land, who we are and what separates us, and we'll start talking about kind of how the product works. But, high level, who we are a leader in Kubernetes backup, right? So we provide cloud native backup, restoration, disaster recovery, and application mobility capabilities. So really important in that we are focused on backup. We are a backup company. So Veeam acquired Kasten in October of 2020, recognizing Kasten's position in the marketplace as being the leader in Kubernetes backup. So it's a strategic advantage for us. We are now all Veemers, or at least Matt and I, everyone presenting in this call. Just strategic advantage to be able to back up these workloads, right? And it is fundamentally different than traditional VM backup. And last point here, and I'll attribute the credit of this to my colleague Matt Schmidt. He was the one that really kind of highlighted this when I built this slide. But Veeam is not a storage company, right? We're not trying to sell tin. We're not trying to sell disk. it's not just an add-on, backup. Data protection is what we do. So very important that relative to maybe some of the competitive landscape is we're not selling backup as a means to sell hardware. We are selling data protection because that is what we do philosophically and what we're passionate about. So we would definitely want to focus on the data protection component.
Yes. So Matt, I'll grab this next session. So really what separates Kasten from other offerings that are out there is we have a very fine-grained model for doing backup and DR and application mobility. And what enables us to have this fine-grained capability is the fact that Kasten is 100% born in the cloud. It's cloud native. And we've actually taken this a step further as that last line of defense for disaster recovery in the event that there's some sort of breach and the SOC has been bypassed. We have a level of encryption of the data at rest and in motion inside. It's known as FIPS 140-2, which is really important. And also, just recently, we are part of an offline hardened repository that's known as Iron Bank. And what that does is we build our images for some entities within the US public sector using all the ingredients or the third-party applications that have already gone through the scanning process and that reside in Iron Bank. And as a result of this additional layer of scanning 4 different ways, that feedback comes back to Kasten by Veeam. It feeds into our engineering lifecycle. So all of the consumers of Kasten by Veeam benefit, not just those that are consuming the technology from Iron Bank. But what's also really interesting is Iron Bank creates a software bill of materials that we refer to as SBOM. So the provenance of the image and all the different ingredients that were used to create the image. And also back at Veeam, Kasten by Veeam, we do the same thing for Kasten for our commercial customers that are not getting the application from Iron Bank. So it's just one more step of how Kasten is embracing security by design versus security after the fact. And what's really interesting is all of our engineering is US based. We have 24/7 customer support, either by US persons or we follow the sun. And for very, very secure workloads, we can also support those in what we call impact level 4, impact level 6, and other air gap deployments, which are oftentimes more than what most people need, but it once again demonstrates our security by design approach. Back to you, Matt.
Awesome. Thanks, Matt. Yeah, and I definitely want to underscore too, I think we probably need to add as a bullet here, but worth noting that we drink our own champagne and from an agility perspective, and that we do releases every 2 weeks, right? So our engineering team is constantly innovating, whether that's bug fixes or even feature releases. We don't hold back features waiting for big releases. So really important there from a security perspective, as well as just from a feature and innovation perspective. Definitely we as a company have embraced that cloud first and cloud native approach in terms of our agility. So moving on, just in terms of who we work with, the good news, we are so much like our parent company Veeam, we are a software only solution. Kasten as a product is software only, so that means we essentially work with everyone, which is great. This is near and dear to my heart. I focus a lot in my role on cloud native partnerships. I'm sure some of these names look familiar, but looking kind of left to right, really important to note here, we're not just backing up container images or just persistent data. We can back up applications and we can back up advanced applications and in more than just a crash consistent manner, right? So there's kind of that old saying that snapshots are not backup. That is very much the case, right? When we're looking at these advanced data workloads, things like, we've got Cassandra or MySQL or SQL Server, we need to make sure that we can actually talk to the application in what language it speaks to make sure that when we take our snapshot or take our backup, we can recover from that in a crash consistent way, logical or application consistent way, not crash consistent. So having that ability to actually get into the application is a real key differentiator for us. Something we're very proud of. This is a part of, I know Matt had mentioned the CNCF earlier. This is part of the Canister project. We just donated this open source project to the CNCF, and Canister. Essentially, if you want to back it up, you can using Canister blueprints, right? So you can obviously use traditional kind of snapshots, storage-based backup, but also, for this application awareness for these advanced workloads, we can do that using Canister. Moving to the right here in terms of Kubernetes distributions, this is not all of them that we work with. These are just a subset. But again, hopefully some of these logos or names are familiar with those on this call. Long story short, as long as it's a Kubernetes compliant distribution, we can run on it. We can back up the workloads on it. Key ones that we see in the field a lot are things like Red Hat OpenShift. We see Mirantis. Not Mirantis. We do see Mirantis, but we see OpenShift probably the most. EKS, Microsoft Azure, things like SUSE or Rancher, or KE2. But all of these we support, we back up, and we actually can move workloads among, right? So worth noting there too, in terms of that hybrid multi-cloud story, of being able to kind of speak to these different Kubernetes distributions is really important. From a storage infrastructure perspective, kind of similar story. All of the major providers we work with, right? So whether that's on-premises storage, if you've got a NetApp cluster data on tap array in your data center, we can absolutely, through their Trident CSI driver, we can talk to them. Any of the major hyperscalers, whether it's via CSI, that's the container storage interface, which is the standard, or what we call in-tree storage. So traditional, more Amazon EBS, we have that built into the product as well. Google's storage as well. So really, any big cloud storage provider we can talk to, but obviously anything that has a CSI driver that supports volume snapshot and volume restore, we can then back up those persistent data workloads. I think there was a question earlier about making sure, containers are ephemeral. What about the data that runs through the containers? That's exactly what we're focusing on, right? We're not actually focusing on the container backing up. We're backing up the data the container is using, or what we call persistent volume claims. And then moving to the right, just security services. This is, again, somewhat of a subset, but things that we can integrate with, and you can do some really, really cool and dynamic things. So Kyverno, in terms of from a policy perspective, from making sure that we have enforcement on our cluster. So maybe ensuring that a workload that wants to be scheduled on our cluster actually has a backup policy applied, right? So we'll touch upon it more in a minute here, but Kasten K10 by Veeam, we are a Kubernetes native application. So that means anything that is Kubernetes native that can pass YAML, they can essentially create these CRDs within Kasten as well. So you can build this as part of your pipeline, as part of your continuous innovation, continuous deployment. You could actually build in to make sure that as you push your workloads or make your releases, we automatically apply backup policies to ensure that our data is backed up and that our applications are backed up. And really important there too, I know, again, speaking from experience, kind of being in that hot seat, just the ability to have a quick kind of reset button as well, right? So, we hear a lot of customers or prospects talk about, everything's in the pipeline. If something breaks, I'll just push, revert and push back. But when it's 11 p.m. on a Saturday night and you're trying to do a release, the last thing you want to do is have to rewind Git and go back a few commits. Where with Kasten K10 we can actually hit the easy button to restore all of our applications back to the state, and you can do things like with Open Policy Agent or Kyverno and essentially create these backup jobs and also create a restore point prior to pushing this code into production. So again, getting really clever with how we're using our automation in our CI/CD pipeline. Matt, anything to add?
Yeah, I just want to do a time check. It's 1:42 now. We've got a series of questions that are in the Q&A. We can keep on going or start addressing the questions. What do you think?
Yeah, absolutely. Let me go to the next slide. I do want to get at least to the next slide, and then let's quickly do a peruse of some of these. We talked about Kube Campus. Will IT ever have to worry about being unable to recover their data if a Veeam database gets corrupted? So good question here. So in terms of Kasten, we have DR built into Kasten, so you can actually protect our data or a backup catalog, if you want to call it that, and essentially export that catalog to mutable storage. So again, we are Kubernetes native. So the way we treat it is, look, if you lose a cluster, don't try to restore your worker nodes. Rather restore your data. So we actually tell our customers our DR approach is to spin up a new instance of K10 using something like Helm or an operator if you're using Red Hat OpenShift, and essentially rehydrate Kasten with its catalog information, which is immutable, right? So we can either restore from an earlier restore point that we know is not corrupt, and if it's immutable, we know it's not been tampered with, and we can essentially reseed our database and then restore our workloads from there. So good question there around disaster recovery.
So there's another question here about how does Veeam guarantee enough resources to back up, such as elastic demand of containerized apps, which are scaling up or down constantly?
So yeah, interesting question there. I saw that come across earlier. So important to note. So from a Kasten perspective, we are not the Kubernetes cluster, right? We are backing up workloads on the cluster. So from a cluster sizing perspective, that would somewhat depend on who you're using as part of your Kubernetes deployment, whether that's an AWS or on premises or like OpenShift or just plain vanilla Kubernetes. But from our workload perspective and our resource consumption, because we're Kubernetes native, I'll keep on saying it, and it's also on this slide, which is why I want to get to it. But we actually spin up workloads and spin them down to perform our backups, right? So talk about kind of that earlier problem I know Matt had talked about in the presentation earlier, is having to size for peak load. Is we essentially only consume the resources we need when we need them, and then we give that back to the cluster. So really important in that we're not always sitting there chopping compute resources, which particularly for public cloud providers can be expensive. As we perform our backups, we'll spin up the number of worker pods that we need, or backup pod, data mover pods. That's what I was going for, based on the number of PVCs and size, and then we'll move those workloads, whether it's to a different S3 storage or locally, and then we'll spin them down once we've finished our backup job.
Yeah, so I can give you another question. What are the key differences in how Kasten by Veeam backs up containers versus VMs?
So good question. So yeah, in terms of how it's fundamentally different in that, so I guess you look at Veeam, VMDR, and you could point it at a VM, whether that's via vSphere or an agent that lives on the VM, and protect that. And essentially, you could take whether it's vSphere, a snapshot or equivalent, and backing up that whole VM. Whereas when we're looking at Kubernetes, it's fundamentally different, right? In that our applications are spread across multiple pods, potentially multiple containers, but also multiple called PVCs or persistent volume claims. So we need to be able to interrogate those Kubernetes specific resources. It's not just a set of files like we have with VMs. We have a mix of both kind of descriptors of our application, things like secrets. That's a really important one too. So we can get very granular in terms of what we back up and restore, and that you can be specific, similar to Veeam in terms of, I guess, be able to kind of see files that you've backed up and restore specific files. We can do the same thing within Kubernetes or container infrastructure, but because it's fundamentally different, we have to look at Kubernetes kind of in a different way. So you can kind of draw an allegory in terms of how VBR talks to maybe a vSphere or maybe Nutanix AHV is somewhat how we talk to, I guess you could say, a Kubernetes cluster. Except we are in the cluster, and we are, so I guess it'd be similar to, I guess, if VBR was deployed as a VM, but we can interrogate everything around us and then, of course, back it up. So custom resources, persistent data, all of that.
Interesting. Here's another question. How does Veeam back up large sets of Kubernetes manifests? Does Veeam protect the data and the persistent volume as well?
Yep. So that was the question I saw pop up earlier. So long story short, yes, we protect both persistent data as well as the application descriptors themselves. One use case we see a lot is, let's say the secret is a great example. Maybe a secret gets accidentally manipulated or a config map gets changed. We can easily restore just that config map. And the nice thing in terms of how we do our backups is we can keep both on cluster as well as off cluster, right? So we can export to anything like S3 compatible storage, something like a MinIO or Azure Blob we support, or any NFS. We can essentially export that off the cluster. And then we dedupe and encrypt that out of the box, right? So talk about security first. You can't turn off encryption. So by default, we actually seed our own encryption key. It's AES 256. That's part of the FIPS certification you mentioned earlier, Matt. But we also do support third-party key management systems like things like HashiCorp Vault or Amazon Customer Managed Keys to encrypt that data. But it is encrypted before it is sent and deduplicated. So you'll often see in our interface, you can see what's on cluster and then what's actually exported. That export number is always a lot lower because we deduplicate and make sure we're not consuming unnecessary cloud resources.
So here's another question. Can Kasten by Veeam back up actively running containers without impacting performance or requiring them to be shut down completely?
Absolutely. Yes. Yeah, we do not require that. And that's part of, I guess, talking about canister blueprints is, we don't need to stop containers or pause or stun, because that's a common issue. I know traditional vSphere backup is having to stun infrastructure. SAP, I know there's very sensitive workloads that can be sensitive to stunning. We don't have that same kind of issue within Kubernetes. We are able to back up as they are running, and then using something like a canister blueprint, we can do things within databases such as maybe a pause reads and writes temporarily just to perform our quick snap, but then immediately resume them. So we're not shutting it down or we're not stopping it, but it does give us an ability to make sure the application is in a state that can be backed up and then, of course, restored later. So it's kind of, I guess, yes and no is the short way to answer that, but absolutely can back up running containers. We, based on the application, we may need to do some things that provide us that logical backup, but you don't have to shut it down or stop anything.
So here's another one, because Veeam is very well known, last over 17 years doing backup recovery of bare metal and hypervisors. The question here is there any level of integration between Kasten and Veeam backup and recovery?
Yes, good question. So if you're an existing Veeam customer, we can use Veeam VBR as a backup export repository. Caveat is you have to be running the vSphere CSI driver. That's how we're able to do that. But yes, we're able to integrate that way. But even if you're not doing an on-premises Kubernetes cluster with something like VMware Tanzu or using the CSI driver, you can absolutely pull in. There's a plugin within the VBR interface that hooks into your Kasten K10 instances that lets you see the status of your backup jobs and check from the VBR interface. So yes, definitely have some integration points there.
So we could we have some other questions here, but I think we have some interesting ones as well that we've been gathering here. So one is, over the past 7 years, we've witnessed the accelerated adoption of cloud native workloads, as we've been talking about in Kubernetes. Can you give us a bit of background of how things are changing as a result of the innovation since containers and Kubernetes have started to become mainstream?
Absolutely, yeah. So certainly I think one of the biggest changes is just the velocity by which organizations can release updates to their applications, to their code. But also, obviously, we need to make sure that the entire organization can keep up with that velocity, right? So it's empowered developers, but it has introduced some of these things that we discussed today, and making sure that we have to actually protect this data, protect these workloads, easily be able to revert if we need to. So I think that's definitely a consideration, is making sure that we can keep up with the pace of our developers. Supporting multi-cloud is another one, right? So, the beauty of containers, we can deploy them anywhere, but the crux of it is we can deploy them anywhere, right? So being able to talk to multiple clouds is definitely kind of a change. Whereas, in the past, you kind of had your SAN or your array in your data center, and based on what your storage admin carved up from a LUN perspective, that's what you got. Now it's a little bit, I won't say the Wild West, but if you try to enforce with the stick rather than the carrot, sometimes you have developers that might go rogue and do that shadow IT kind of approach and just go spin it up in AWS, and then suddenly the business is sitting with a bill that they weren't expecting, right? So being able to kind of account for that and make sure that we can either move those workloads or at the very least, help ring fence with things like using Open Policy Agent or Kyverno for Kyverno policies.
So here's an interesting question. There seems to be some confusion around, we hear stateful and stateless, but there seems to be some confusion around those topics as it pertains to applications, Kubernetes. So customers may think they don't need to back up data protection if it's stateless. How can we put all this in perspective and help folks understand what is stateful, what is stateless, and what is the ground zero truth in terms of needing to back up a Kubernetes environment and providing DR capability?
Absolutely, good question. And I think the go-to answer is, look, if it's stateful PVCs, persistent volume, we're looking at data attached containers, which is absolutely the case. But I think stateless is somewhat a misnomer too, though. Even if you don't have persistent volumes in your cluster, if you have things like config maps or any data that's measuring state, right, of an application. So, and again, Matt, I'm going to steal one of your examples, but I love it because it's so illustrative. But a stoplight, right? So if you've got a four-way intersection and your stoplight's functioning normal, obviously one side's red and then maybe your light's green. if we lose power, the reset, maybe the lights will come back on, but we don't want them all blinking green, right? Because if that happens, then we have quite bigger problems on our hands than just the lights being down. So similarly, that might be considered a stateless workload, in that we're not writing to a disk, but maybe we're capturing that binary 1 or 0, or I guess maybe 0, 1, 2, if you're looking at different colors of what was eliminated when, be able to kind of recover that in a way, right? Looking at things like secrets or config maps or CRDs, custom resource definitions in Kubernetes. Even that is something that we need to make sure that we're protecting. So it is kind of a fine line in terms of, we don't want to back up our Kubernetes cluster, right? Our worker nodes, or etcd, for those that are familiar with Kubernetes and kind of where the rings are. But at the same time, we need to make sure that those resources that are part of our applications, we can protect that. Because just hitting redeploy for our application may get the lights back online, but what about that time in between, or do they blink green in between when we redeploy, and or what state do they get reset back to?
Interesting. So as we approach the end of our time together, can you share some high-level details as to how the Kasten K10 by Veeam solution can help organizations on their cloud-native journey or hybrid cloud journey, and specifically what features differentiate Kasten in the marketplace?
Awesome. You've teed me up like I'm playing T-ball here, Matt. I appreciate it. So this slide, gives a really high level, but to kind of circle around here in terms of from a product perspective and what's a key differentiator, I think that one of the biggest ones, and I'll harp on it, I've said it and I'll say it again, is being Kubernetes native, right? So everything that you do in our web interface, so skipping down kind of to the ease of use, we have a very nice, friendly web interface. Everything you do in that web interface, you can export the YAML for. So be able to create a backup job and then build that as part of your pipeline, versus other backup solutions that might just be a bolt-on, or maybe a physical block that they are used as a backup appliance is just hooking in externally to a Kubernetes cluster. You're not afforded those same integration capabilities, that same flexibility. Security everywhere. From a product perspective, we talked about encryption. We have our FIPS certificate for our encryption standard we're using when we're moving data. So really important that we think of security from the outset. We are the last line of defense against ransomware. So we need to make sure we support things like immutability and making sure that we can protect this data in a worst case scenario, right? So there are a number of offerings out there. There's an open source solution, but doesn't necessarily support immutability. And obviously there's no support to call in the event that you are hit with ransomware. It's a key differentiator for Kasten by Veeam is as having that support and that assurance. Moving down here, kind of back to that ease of use. We talked about the web interface, but really providing that nice friendly GUI and also making sure that we can enable administrators. We talked about that skill shortage, letting our platform engineers and administrators focus on moving the ball forward rather than keeping the lights on. By making backup easy and seamless, you can focus on the things that really help move the business forward. And then full ecosystem support, I kind of touched upon with Kubernetes native, but we've shown that slide earlier around different Kubernetes distributions, storage providers, hyperscalers, and what have you.
So, Matt, I think we're at the end of our time, but for those on the call wanting to learn more, definitely check out our website, kasten.io or veeam.com. And there on one of those estates, you can download brochures, papers, access videos, etc., about the fully featured Kasten K10 by Veeam. You can also download our production software, the exact same software that our paying customers use in production. You're able to download it and use it for no cost, up to 5 worker nodes. And if you'd like to know what a worker node is, you can always reach out to Matt Slaughton or myself, or even reach out to info or support at veeam.com or Kasten at veeam.com, sales at veeam.com. Any one of these combinations is going to work for you. And we'd enjoy the opportunity to talk further. And just want to thank everyone for joining us this late morning or early afternoon. Any final words, Mr. Slaughton?
I appreciate it, Mr. Schmidt. Always a pleasure presenting with you. And Scott, thank you again for bringing us in. I always enjoy presenting with actual tech. And I guess big thank you to the audience as well for sticking it out and asking some great questions.
Yeah, thanks to both of you for being here. I'll echo what Rob said. Great stuff, guys. One of the attendees. Really great presentation. Really appreciate it. Thank you both.
Thank you.
Thank you.
Bye, everyone.
All right, and I'm going to leave up that slide here with the QR code in this last minute here in case you wanted to grab that. But it is time for our Amazon gift card prize drawing. And the winner of the $250 Amazon gift card today is Andrew Changaway from Pennsylvania. So congratulations to Andrew Changaway. We'll be in touch to get you your card. And of course, we will be selecting the best prize question winner after the event is over. So with that, on behalf of the Actual Tech Media team, I want to thank Veeam for making this event possible, and Matt for a great presentation. And thanks as always for attending and for all of your great questions. You guys really drove this presentation with all those questions. We really appreciate it. So that concludes today's event. Have a fantastic rest of your day.